Welcome to Bot Thoughts by AmTalkSoft. I'm Alex, and Sam is here. Today we're talking money, specifically how to run LLMs in production without your infrastructure bill becoming the largest line item in the company. Sam, is runaway LLM cost actually a widespread problem or mostly a startup horror story?
It's genuinely widespread and it catches teams off guard. The pattern I see repeatedly is, team builds a demo using GPT-4o, it's brilliant, they show it to the CEO, they ship it, and then the monthly AI spend is 3 times the engineering salary budget. The math sneaks up on you. 1,000 daily active users, each making 5 requests, each request averaging 2,000 input tokens and 500 output tokens. That's 2.5 million input tokens and 625,000 output tokens per day. At current GPT-4o pricing, that's around $120 a day or $45,000 a year just for the LLM calls. Multiply that as you grow and you have a real problem.
Let's go through the main levers. Where do teams typically find the biggest cost savings?
Model selection is the biggest lever by far, often an 80 to 90% cost reduction opportunity. Most applications use GPT-4o or Claude Opus everywhere, including tasks that a much cheaper model could handle just as well. A user asking a simple FAQ question doesn't need a frontier model. A document classifier doesn't need a frontier model. A sentiment analyzer definitely doesn't need a frontier model. The strategy is model routing. Identify the tasks in your application, benchmark them with smaller models, and use the smallest model that achieves acceptable quality for each task. Claude Haiku is around 15 to 20 times cheaper than Claude Opus. GPT-4o Mini is around 15 times cheaper than GPT-4o. If 60% of your requests can move to cheaper models, you've transformed your cost structure.
Prompt caching, I keep seeing this mentioned. How significant is it actually?
It's significant and underused. Prompt caching works by recognizing that many requests share a large common prefix, your system prompt, your document chunks, your few-shot examples. Instead of charging you full price to process that prefix on every request, the model provider caches the processed form and charges you a fraction for the cache hit. Anthropic's prompt caching reduces input token cost by 90% on cache hits. OpenAI's similar feature reduces it by 50%. The gains compound with long system prompts or document-heavy RAG applications. If you have a 5,000 token system prompt and you're making 1 million requests per month, moving from cache miss to cache hit on that prompt alone saves you around $4,000 per month at current pricing. Structuring your prompts to put stable content first, system prompt, context documents, few-shot examples, and variable content last maximizes cache hit rate.
Batching, when does that apply, and how much does it save?
Batching applies when you have offline or async workloads, document processing, data enrichment, report generation, anything that doesn't need a real-time response. Both Anthropic and OpenAI have batch APIs that process requests at lower priority in exchange for a 50% discount. If you have 10,000 documents to classify, sending them as a batch rather than as individual synchronous requests cuts that cost in half and requires no changes to your code logic. The trade-off is latency. Batch jobs may take minutes or hours rather than seconds. For anything where the user is waiting, batching isn't an option. For background processing jobs, it's almost always the right call.
RAG systems have interesting cost dynamics. You're retrieving chunks and putting them in context. How do you optimize that?
RAG cost optimization has 3 angles. First, chunk size and retrieval count. Many teams default to retrieving 5 or 10 chunks of 500 tokens each, which adds 2,000 to 5,000 tokens to every request. Often 3 well-chosen chunks of 300 tokens each give comparable or better quality. Profile your retrieval quality versus token count trade-off for your specific application. Second, re-ranking before context insertion. Retrieve more candidates than you'll use. Run a fast, cheap re-ranker model to score them. Insert only the top 2 or 3. Cross-encoders like Cohere's re-rank API or open-source models like BGE re-ranker do this for a fraction of the cost of a frontier LLM. Third, context compression. Tools like LLM Lingua use a small, cheap model to compress retrieved documents before inserting them into the expensive frontier model's context. Research shows up to 3 times compression, with less than 5% quality loss.
At what point does self-hosting open-source models make more economic sense than paying API fees?
The crossover point is around 2 million tokens per day for most teams, though it depends heavily on your model choice and infrastructure costs. Below that threshold, the fixed costs of GPUs, engineering time to maintain the serving infrastructure, and operational complexity almost always make API pricing cheaper. Above it, the economics flip. A single A100 GPU on AWS costs around $3 per hour, roughly $70 per day. Llama 3.170B can serve around 150,000 tokens per minute on an A100. That's 216 million tokens per day, at a cost that would be around $12,000 per day at frontier model API pricing. So self-hosting a 70B model on an A100 is roughly 170 times cheaper per token than the equivalent API call once you're at that scale. The models to consider: Llama 3.170B for general tasks, Mistral and Mixtral for instruction following, Phi 3 for smaller memory-constrained deployments. Use VLLM or TGI for the serving layer.
You can't optimize what you don't measure. How should teams instrument their LLM cost tracking?
Track cost at 3 levels. First, per request, log input tokens, output tokens, model used, latency, and estimated cost for every LLM call. This lets you find the expensive outliers. Second, per feature or use case, aggregate per request data to understand which product features are driving cost. Often one feature is responsible for 70% of the spend. Third, per user cohort, identify whether certain user behaviors generate disproportionate costs. Langfuse, Phoenix, and Helicone all provide LLM observability with cost tracking built in. Set budget alerts so you're not surprised at the end of the month. And run cost forecasting based on your DAU trajectory. Knowing that you'll hit $50,000 per month in 60 days gives you time to optimize before it becomes a crisis.
If someone has an LLM application with a rising cost problem and has to choose just 2 or 3 things to do this week, what's the priority order?
3 things in this order. First, instrument and measure. You need to know where the cost is actually coming from before you can optimize anything. Add per request cost logging today. Second, model routing. Take your highest volume request type and benchmark it with cheaper models. If Claude Haiku or GPT-4o Mini passes your quality bar for that request type, switch it immediately. That's usually a 10 to 20 times cost reduction on your highest volume call. Third, enable prompt caching. If you have a long, stable system prompt, this is usually 15 minutes of configuration for a 50 to 90% reduction on prompt token costs. Together, these 3 changes often reduce costs by 60 to 80% before touching architecture or adding infrastructure.
Summary time. Model selection is the biggest lever. Use the smallest model that meets quality requirements for each task. Prompt caching can cut input costs by 50 to 90% on stable prompts. Batching saves 50% on async workloads. RAG optimization through re-ranking and context compression reduces tokens significantly. Self-hosting makes economic sense above roughly 2 million tokens per day. And measure first, you can't optimize what you can't see. Sam, final recommendation.
Open your cloud billing dashboard right now and look at your LLM spend trend. Then add Langfuse or Helicone to your application this week. Both have free tiers and both will show you per request cost breakdowns. Once you can see where the money is going, the optimizations become obvious. And read Anthropic's documentation on prompt caching. It's one of the fastest ROI changes you can make if you use Claude.
That's Bot Thoughts for this week. Practical topics like this are exactly what this show is for. Subscribe on YouTube and Spotify, new episode every week. And if you want to support what we're building, buy us a coffee at buymecoffee.com/AmticSoft. We appreciate every listener and every coffee. See you next episode.